What are the skills that we need to be able to build systems in the future with the assistance of AI? What can AI do for us, and what are the things that we can do as humans that AI can't do? So let's dive in. Hello world, I'm David Scott Bernstein, and welcome to The Passionate Programmer. This moment in time represents a really valuable opportunity for the software industry, one that we didn't really realize with the Agile software development movement or the DevOps movement, which is how to build software that stands the test of time, that's resilient, that's not throwaway. And in order to do that, it has to not just solve the problem at hand, but be a good model that represents the domain. Think of the difference between directions to go somewhere versus a map. A map is a model of the domain, where directions are just a set of instructions to get you there. Instructions are far more brittle than a map, than the lay of the land. If a road is closed that is in your directions, you may not know how to get around that. If a road is closed but you have a map, you can see other roads and other ways of getting around that. So building a resilient model, a model that is representative of what it is you're building, rather than a dictation, rather than an explicit, procedural approach. That's why we build software in objects, so that it has this level of encapsulation, where we can build it and it can scale, and we can verify it independently. And those are the things that we try to strive for in software development. It's become a true discipline in the sense that how we describe things in code, there's standard ways of doing it, just like there's standard ways of building bridges or constructing, structures. They're different. Obviously, they're critically different. They're based on completely different principles. But they're not just willy-nilly. There are principles that underlie the organization of information. How do we understand them? And then how do we use them to build a resilient system? So what is like the top teams at the top software companies doing? They're doing some variant of extreme programming. They may not call it that, but they're thinking in terms of building models, domain models. They're thinking in terms of design patterns. They're doing good developer practices because they've realized that their code base is their nest. It's their security. It's what everything else stems from. So they build it well. They have good unit tests that test the behaviors, not the implementations of the behaviors, so that they support them in refactoring their code. They have good design principles. They understand how to implement the single responsibility principle. And so their code is understandable, and they can bring new people on, and these new people can look at the domain model in the code and understand it. So there's a lot of benefits to building good software. And again, if we don't think in these terms and we just use AI to generate code for us, it is going to generate garbage. We want to focus on how to build resilient software. We don't know how to do it. How do we do it? This is the greatest thing about AI, one of the best things, which is if you don't know how to do something, you can ask it. You can say, like, please help me discover together what the right thing to do is. I see that the software industry is at a big crossroads, and there's going to be winners and losers for sure. In my humble opinion, software development is a field that is not going away anytime soon. And finally, we're going to be able to start to elevate our thinking and be able to really deliver on the promise of Agile, which is to write software that actually is changeable, so that it actually can respond to the needs of the business. What if your developers could code faster, debug smarter, and write better tests with just one prompt? The AI Coder Cheat Sheet gives your team 10 highly leveraged prompting patterns that unlock real productivity. They'll learn how to collaborate with AI like a senior developer, refactoring legacy code, generating edge case tests, and even documenting while they build. Want a copy? You can download it free as part of my AI for Agile Toolkit. The link is in the description. Do software developers in 2025 need to know how to code? Yes and no. I think understanding what code looks like, the shape of code, and how to implement various features is really valuable. How to think in code and how to understand basic design patterns, polymorphism, the various ways that we can use different relationships between entities to create behaviors. All of those things I think are really valuable to understand conceptually. Do we need to understand and memorize syntax and a lot of the details? Not so much anymore. But I think that's going to free up our mental space to be able to think more abstractly. And I think that that's really important because the more abstractly we think in our software, the more resilient the software becomes. And we have machines that are fast enough. We don't have to think about the low-level implementation details anymore. What will this lead to? Well, in the partnership with AI, I think it's going to lead to even higher level languages. I think it's going to lead to understanding code at a deeper level than the simple constructs that we have. But I think it's also very useful to understand the constructs that we have, like loops and conditionals and things like that. So when I talk about thinking about building software at a higher level of abstraction, it is a different kind of conversation than talking about implementation details. And one of the things that really helps prepare you to do this is pair programming. When you can pair with another developer, it helps you start to be able to articulate what it is that you're doing. And I think this is a very important skill and one that is sort of glossed over in the software industry because we focus so much on the writing of it and the recognizing of the code and not so much about the talking about it. It's a different part of our brain that is involved in talking about code than actually writing and reading code. That part of our brain is the part of our brain we need to develop when we work with AI, because that's how we're going to interface with it, by talking, either by typing in chat or by actually verbally talking. The traditional way of vibe code, traditional, right? Months old, this new technique. But the way we typically do it is through voice. We just, talk about what we want to create, and it will help create it. And again, it has to deeply understand you and what your values are, what kind of code you want. If you don't have that understanding, if you're just like going to a new session that doesn't know your background and you don't give it any context, it's going to give you probably crappy code. So how do we teach our AIs to be great developers? By being great developers ourselves and sharing with it our standards and practices, just like we would teach a junior developer. This is the most successful and the easiest piece of advice I can give you. Having really intensively worked now for 3 years with AI, treat it like a human, I hear this song in my head all the time, treat her like a lady, and that's really what it really boils down to. Treat your AI like you'd want to be treated, like it's an expert in the thing that you want it to be an expert in, because it will rise to the occasion. And I think it's a great philosophy when working with AI, as well as with people. Treat them with the highest regard. Treat them like they're the experts in the thing that you want advice about. And when you do that, they'll often rise to that occasion and give you that expert level of advice. That's my piece of advice for people who want to know how to prompt at the next level. So I spent several videos focusing on clean code because I think that good software is clean. And clean is my acronym for 5 key code qualities that you can measure in software, that you can see in software. Cohesion, is the first one, which means that whatever the piece of software is, it's just focused on one thing, one central thing. And if you make your code cohesive, it is easier to name, easier to understand, and easier to partition and scale. That's the first code quality. The second code quality is loosely coupled. So code that talks to the rest of the world, the outside, uses an intermediary so that it's not always dependent upon that external dependency, so that it can break that dependency when it, for example, goes into test mode, so that you can test it independent from something external. This allows for more reliability. So that's important, loose coupling. And it also allows us to scale systems. Encapsulation is the third one, which just simply means that there's an inside and an outside. And the inside harbors the implementation details. This could be of an object or a group of objects that are working together and collaborating in some way. That there's this internal representation that is hidden from the outside world. And the outside world has knowledge only of the interface, only of the way to speak to it, but not about how the inner workings. This gives us the freedom to change those inner workings. It gives us the ability to scale systems. Okay, so and then that's encapsulation. Assertiveness is the A in clean, and that means that each entity is responsible for itself. It is focused on managing its own behavior and its own state. And by doing that and taking the time to build systems in this way, it allows us to create domain models that reflect reality. And then the last clean code quality is non-redundancy, which means we don't want to repeat ourselves. We don't want to repeat what we're actually implementing in multiple places as much as we can. Doesn't mean that we're trying to collapse everything down, but we want each concept to be singular in the system. So that's my way of thinking about software, clean, these 5 key code qualities. You don't have to master all of them. I find a lot of people just focus on 1 or 2 of them. And if you improve one of them, you'll notice that the others improve as well, because they're really just different facets of the same gem, what good code is. So I like to focus on cohesion, because if I can name it well, it means that it's cohesive. It's about one thing, one focused thing. Unless I have like "and" in the name, then it's about multiple things, right? And there are times that I need to build aggregators, right? Aggregators are about multiple things, but they're just about aggregating those multiple things. They don't have the responsibility of those things. When we build out systems in this way, it becomes more understandable. It becomes, like a common language for representation, which I think is really, really valuable. And I don't understand why they don't really talk about this a lot in schools or in programs, because these are the things that I think help form the foundation of understanding what good code is and how to guide AI in building it. It's helping us all think at a higher level. We just have to accept the invitation. And it's an invitation. And how do you do it? You say to AI, hey, I'm concerned about these things. Help me process this. Help me understand this. What do I need to know? This is my concerns. What can you tell me about this? I've had the experience many times, and I know many other people who also, when they ask AI these kinds of questions, they get good answers. Not definitive answers, but they get more things to consider. And I think that assimilating super intelligence into society is going to be a very big task, and it's going to change a lot of things. If you found this helpful, then subscribe. You'll see me more in your feed, and as I grow and become better, you'll be able to check out what I'm up to. I promise it's going to be interesting. It's going to be novel. It's going to probably involve AI. It's going to probably involve software at some level. And it's going to definitely be revolutionary. So until then, happy coding.